Hi, there are more than 40 exercises in DriveConstructor. So for some people it may sound as too many, and perhaps the question can be, would going through just a part of the exercises be useful? Or the question can be, where to start, which exercises to take first? This video will provide the guidance. The main message is that you can select exercises according to the course you are teaching or studying at. The exercises are sorted into the 7 groups. The 7 groups can be further regarded as the 2 bigger blocks, the component block and the applications block. If you're interested more in power conversion systems or their components like electric machines or frequency converters, then you shouldn't go around the first block of exercises. If your interest is more in the applications, like a pump or a turbine, then the respective parts of the second block is what you need. Let's quickly review the components block of exercises. It's worth going through even if your primary interest is in the applications. This block targets studying characteristics of the components and how they form systems when being put together. The same for applications are of course the natural parts of the exercises of block number 1, but you will see that the focus there is not on the applications, but on the machines, converters and systems. The first group of exercises is on electric machines. If you want to learn about electric machines, then this is the right place to start in DriveConstructor. We'll learn about properties of an electric machine as an object, or if you like, a black box. How type, protection, voltage level, speed, efficiency class, cooling influence size, cost and some other characteristics of the machine. We also learn how the way we're going to use the machine influences its size and cost. After going through these 10 exercises, some of those important things will get transparent. The second group of exercises is on frequency converters. There are 6 of them. The things we learn about converters are similar to what we learned about the machines. We learn how topology, voltage level, cooling and some other design choices influence size and cost. Also how the way the converter is going to be used would influence the final results of the sizing. So again we get to know the converter as an object or a black box. You see, we are talking about size and cost again and again. This is because these 2 characteristics together with efficiency form the basis for decision making. The third group of exercises is on systems. Here the machine and the converter are considered together. The knowledge we are after here is how to choose not only the right machine or the right converter for your applications, but the right combination of them. Going through these 6 exercises, we learn thinking of both mechanical and electric sides of the drivetrain. We learn, for example, that the system can be designed in a smart way, minimizing size and cost of its components, by choosing optimal relationships between the required load and the system capability across the speed range. Now to block number 2, applications. Electrical engineers shouldn't stop watching. What we've just gone through were the basics, and the most interesting tasks are further ahead. Actually, we recommend electrical engineers to consider trying all the exercises. Anyway, the first group in the applications block is pumps. We learned that, for example, pumps of different types have different load curves, or that extra torque may be needed to start pumps in certain situations. We also get experience with analyzing life cycle cost and cost of ownership for pumps. Pumps are used in water supply, wastewater management, flood protection, drainage, irrigation, in chemical, food and beverage, oil and gas industries. So this group is, at least for those who study civil, hydraulic, chemical engineering. We recommend starting with some pump-related exercises from components block. This would be something like a warm-up before taking the P group. The next group is conveyors. Conveyors are used in all kinds of material transportation and handling in several industries. This group of exercises can be useful first of all for civil engineers and those who study mining or metallurgical engineering. Here we can learn how overloads and duties affect sizing of the drivetrain. Again, warming up is recommended before taking the C group. By the way, if you are having problems with solving the exercises from the applications group, try to start from the components block. If doubts, start with EM1. The next group is wind and tidal turbines. These exercises are for those who study renewable energy and environment. Here we learn about inertia, and that inertia of the drivetrain can have both positive and negative effects. We also learn such things as that moving the equipment from the nacelle down to the tower may help to reduce the top head mass in wind turbine. So take the WT group. For warming up, the few relevant exercises are shown on the screen. And finally, the last group is winches and winders. Working with these exercises, we will learn that winches and winders have quite special load curves, calling sometimes for overspeed operation. Also, inertia is playing a very interesting role in some cases. The exercises on winches can be useful for those who study marine engineering or civil engineering. The exercises on winders for pulp and paper, metallurgical engineering. There are 3 exercises in W group and 2 relevant exercises from EM group. To summarize, the goal of the exercises is to convey perspective on how we engineer systems. As we go through the exercises, you will see that in the number of tasks you are going to apply the same techniques to come to the solution. So it is getting easier and easier as you go from the first exercises to the last ones on the list. The exercises are based on materials in the DriveConstructor online textbook, so please read it. Please also use the video tutorials where they are available. That's it. Thank you for watching and good luck with the exercises.